In this video, we are going to look at geometric sequences. So the term geometric means that you are multiplying by some value to get from one term to the next. So in this first example, they have given me a formula that tells me that the nth term is going to equal to -2 times, basically this is saying the previous term. So we're multiplying by -2 to get to the previous term. So they started out, they told me the first term was 7, and they're asking me for the first 5 terms. Now if you actually plug into the formula for this next one, so a of 2, my n is 2, it says take -2 times a. When you do the 2 minus 1, that just says -2 times the first term. So when I take -2 times my first term, which was 7, then I find that my second term is -14. And so for my third term, it would be saying take -2 times my second term. So when I take -2 times my second term, -2 times -14, I'm back to a positive this time, 28. And so as we keep going, so then times -2 again, we would see that our fourth term is going to be back to negative. It's -56. And then finally for our fifth term, when we multiply by -2 again, we're back to positive, and we would be up to 112. Okay, so in general, an nth term in a geometric sequence is going to be found by taking a first term times whatever ratio you have to the power of n minus 1. So this, in the second example, they're asking me to find my 7th term, and they are telling me here that my first term is a 4, and they are telling me my common ratio is 3. So if I'm looking for the 7th term, I would raise that to the power 7 minus 1. So the 7th term in this particular sequence is going to be 4 multiplied by 3 to the power of 6. And so if we actually get on a calculator and figure out 3 to the power of 6, so we get 729. And then when we multiply that 729 times 4, I get a value of 5,103. So my 7th term is 5,103. Okay, then we see an application problem here. We have a professional baseball player that signs a contract with the beginning salary of $6 million. Ooh, wouldn't that be nice? And it says that's for the first year, and then they get an annual increase of 15% per year, beginning in the second year. So that is, beginning in year 2, the athlete's salary will be 1.15 times what it was the previous year. So this is a clue that this is a geometric sequence. When they're multiplying and they're doing times a certain amount, it's geometric. If they were saying that they just get a flat amount added to their salary each year, say an extra million each year or something like that, then that would be arithmetic. So in this case, we have something that's geometric, and we are looking for what the salary would be in year 7. So using our geometric formula here, we're looking for when n is 7. So if we take the first year salary, which was the $6 million, and we multiply that by the ratio, so each time they're multiplying his salary by 1.15 to the power of, if we're looking for the 7th year, then we go to the power of 7 minus 1. So his 7th year salary would be the $6 million times the 1.15 to the power of 6. And so we would get on a calculator at that point to multiply it out. So I brought a calculator in here at the bottom where I multiplied it out, and now you can see that his salary would be $13,878,364. And then it's 59 cents, but in the problem they're saying round it to the nearest dollar. So the 5 here would round that up to a 5. So $13,878,000, $878,365 would be his yearly salary for that 7th year.